Any form of interaction between a user and a program refers to a user dialog. For example, entering data, choosing a menu item, clicking a button, or clicking or double-clicking a list entry. The current SAP programming model is single-screen transactions. The aim of the current SAP programming model is to replace long, nested screen sequences with single-screen transactions. Single-screen transactions are easy to use and improve the usability of an SAP system. Input and data screens are combined in one window. Combining the screens saves the user from unnecessary navigation and ensures the correct business context. Single-screen transactions provide program sessions that best fit user authorizations. A single-screen transaction allows a user to directly access the objects to be edited and limits the selection area by using a filter, a tree structure, or the last edited object. After saving data to the database, the user can view the edited object again to check the changes made.
The figure shows an example screen layout of transaction FB60, which is redesigned in accordance with the new programming model. The screen is divided into the following sections, each allowing you to perform different functions. Object selection. You can select the object you want to edit from a tree structure. Object ID. You can edit the key data and attributes of the whole object. Details of object. You can select sub-objects for editing. Application functions. Only a few functions are available on the application toolbar as a result of the new single-screen transactions. These include display functions such as showing and hiding screen areas, creating new objects with templates, or toggling between different sessions of a program.
The figure describes screen programming.
The following types of programs cannot be executed directly. Function group type F. A function group or type F can contain function modules, local data types, global data objects, and screens. Include program type I. An include program or type I can contain any ABAP statement. Interface pool type J. An interface pool or type J can contain global interfaces, local data types, and constants. Class pool type K. A class pool or type K can contain local data types, constants, global data objects, local and global interfaces, and local classes.
In the simplest case, your program consists of a single source that has all the necessary processing blocks. However, to make your program code easy to understand and reuse its parts in other programs, for example, for data declarations, use include programs. Whenever you create a program from the Object Navigator, the system prompts you to create it using the with top include option. Selecting this option helps you to create clearly structured programs. When you create processing blocks, the system automatically prompts you for the include program where the corresponding source code has to be inserted. If you specify an include program that does not exist, the system creates it and inserts a corresponding include statement in the main program.
The figure shows tables of the flight data model used in this course.
The table fields used in this course are as follows. Screens are freely definable objects that are used to display or enter information through input and output fields, lists, and so on. Screens are a form of dialogue between a user and an ABAP program.
Screens allow you to enter and display data. You can use screens in combination with the ABAP dictionary to check the consistency of the data entered by the user and also to provide the user with input help and semantic help. Screens allow you to create user-friendly dialogues with push buttons, tab strip controls, table controls, and other graphical elements. Screens are containers for various screen elements, such as radio buttons, checkboxes, and input and text fields. When the program starts, the system loads its program context and prepares space for the program data objects in memory. Then, the selection screen is displayed. The user enters data on the selection screen and chooses Execute. In a processing block, the program reads data from the database by passing information about the data requested by a user to the database. The database fills a structure with the required data record. The processing logic then calls the screen process before output or PBO. After the PBO is processed, the data is transferred to a structure that serves as an interface to the screen. The data is then transferred to the screen and displayed.
Screen elements include text fields, input or output fields, status icons, group boxes, radio buttons, checkboxes, and push buttons. Screen elements have general, dictionary, program, and display attributes. The elements subscreen, tab strip control, and table control have general and special attributes related to the respective type. You can divide the attributes of an element into the following categories. Attributes that are defined statically and cannot be changed dynamically. Attributes that are defined statically and can be changed dynamically. Attributes that are only set dynamically.
Each screen has a set of administration attributes specifying its type, size, and the subsequent screen. The screen also has settings that influence other properties of the screen and its components as shown in the figure. The administration attributes, screen number, and program identify the screen by its number and the program to which it belongs. Screen numbers greater than 9000 are reserved for SAP system customers. Screen numbers 1000 through 1010 are reserved for the maintenance screens of ABAP dictionary tables and the standard selection screens of executable programs. A screen consists of a screen image and its flow logic. Flow logic is a program that controls how a screen image is processed. For information about programming screen flow logic, refer to the ABAP user guide. Screens have the screen masks, attributes, elements, and flow logic. Flow logic contains the flow logic code, not ABAP statements.
To create a screen, perform the following steps. Set the general screen attributes on the attribute screen. Design the screen layout in the layout editor. Set the field attributes in the field list. Write the flow logic in the flow logic editor.
To create a screen from the object list in the Object Navigator, perform the following steps. Create a new development object with the type screen. Open the context menu for a dialog program and choose Create Screen. In the dialog box, type a number between 1 and 9000 in the field Screen Number and press Enter. The Object Navigator opens the Screen Painter. Enter the mandatory screen attributes such as short text and screen type. Usually the normal screen type is used. Specify the number of the next screen in the next screen field. If you enter 0 or do not enter any value, the system resumes processing from the point where the screen was called after the screen processing is over. You can also create a screen by typing the statement set screen NN or call screen NN, where NN stands for the screen number in the RBAR editor, and double-clicking the screen number.
Screen input or output fields are recommended to be defined by referencing fields or components from the RBAR dictionary definitions for database table or structures. However, you can also reference fields defined in the top include of your program, but the screen fields will miss the input help and the semantic help defined in the RBAR dictionary. To be able to use the fields defined in the top include as a reference for the screen fields, you should activate the program first. The graphical layout editor provides an easy way of defining various screen elements, such as input or output fields, text fields, group boxes, push buttons, etc. You simply choose in the toolbar the element you require and position it on the screen using the mouse. To delete a screen element, select it and choose the Delete Push button. You can move elements on the screen by dragging them with a mouse. To set the attributes of all screen elements, the Screen Painter provides an element list with several views. You can display the attributes of an element from any list. You can maintain the attributes of an element in the layout editor using the attribute window icon or F2 function. In the Screen Painter, you work with RBAR dictionary data types or data classes. If the screen field you create references RBAR dictionary fields, the system displays the RBAR dictionary data type in the format attribute. For elements or templates that do not have an RBAR dictionary reference, you need to enter an RBAR dictionary data type. To identify the corresponding RBAR dictionary data type for a predefined RBAR data type, see the keyword documentation for the RBAR statement select, path select target, assignment rules for individual columns. For example, the following table lists some of the corresponding RBAR predefined data types for the RBAR dictionary data types.
Screens have their own set of keywords that are used in the process before output or PBO and process after input or PAI events of the flow logic. In the Screen Painter, start the Help or Control plus F8 and then choose Keyword Overview. In the flow logic, write module calls. Modules are modularization units of an RBAR program that contain the RBAR statements you want to execute. You can create an RBAR module by double-clicking a module name in the flow logic editor. You can call the same module from more than one screen. If the processing depends on the screen number, you can retrieve the current screen number from the system field SYDYNNR. The modules you call in the PBO processing block must be defined using the module output statement. Modules that you define using the statement module input can only be called in the PAI event.
The following software processors are involved in screen processing for a program. The ABAP processor controls the program flow in a module. The DINPro processor controls the flow logic and prepares data to be displayed on the screen. During screen processing, two sets of data are visible. You work with the global fields of your program within a module. You can create global fields in the top include by using declarative statements such as tables or data. When the screen is sent to the front end, the screen input or output fields are populated with data from the global fields with identical names defined in the top include. A system program transfers the data at the end of PBO. Now the user might change the data and take an action by pushing a button. The data on the screen fields will be transferred to the global fields with identical names in the top include of the program, usually at the beginning of PAI. This action is executed by a system program.
After a system has processed all modules in the PBO processing block, the system copies the contents of the fields in the ABAP work area to their corresponding fields in the screen work area. The screen and its associated ABAP program communicate only if the fields on screen and the corresponding fields in the program have identical names. Before the system processes the first module in the PAI processing block, the system copies the contents of the fields in the screen work area to their corresponding fields in the ABAP work area. Use your own structures such as SDYN_CON for transporting data between the screen and the ABAP program. Using your own structures ensures that the data being transported from the screen to the program and vice versa is exactly the data that you want. Dynamic changes to the attributes of screen elements are temporary. Using dynamic screen modification to modify the attributes of a screen element, you can replace long sequences of separate screens that take more time to program and run. For example, using dynamic screen modification, you can change the attribute of a screen element to decide whether an input or output field is ready for entry. At the beginning of process before output, or PBO, the runtime system reads the current screen into a system table with the line type screen. The system table contains the statically created and dynamically modifiable attributes of each element. Screen name is the unique identifier for a screen element on one screen. However, a text element may be called using the same name as the input element that the text element describes. The figure shows the assignment of fields in the system table screen to the names of the statically created attributes of screen elements.
A screen system table is a system table with line type screen. When a screen is processed, the screen system table contains an entry for each element created for that screen in Screen Painter.
A system program initializes the screen system table at the start of the PBO event for the current screen. To initialize the screen table, the program copies the statically defined attributes of the screen elements to the table. To change the dynamically modifiable attributes, use the structure screen. The system automatically creates this structure and fills it with the values of each line of the system table in the loop. Set attributes have the value 1, and attributes that are not set have the value 0. To change the system table, use Modify Screen within the loop. To find the element whose attributes you want to modify, use Loop on the screen table and query one of these fields, screen name or screen group 1 to screen group 4.
You can simultaneously change the attributes of several screen elements at runtime. Assign all elements that you want to change within a single processing step to a group in Screen Painter. To assign the elements to a group, enter a group name for each of the relevant elements in one of the Group 1 to Group 4 fields. You can include each element in a maximum of 4 modification groups and choose any 3-character sequence for the group name. You can also assign elements to a modification group either in the element list or the layout editor in the Screen Painter. Program your screen modifications in a module that is processed during the PBO processing block. Use a loop through the table screen to change the attributes of an element or a group of elements. Loop at screen where and read table screen are not supported. To activate and deactivate attributes, assign the value 1 for active or 0 for inactive and save your changes by using the modify screen statement. Note that the elements that you have defined statically in the Screen Painter as invisible cannot be reactivated using the statement screen active is equal to 1. Instead, use the statement screen invisible is equal to 0. However, elements that you have statically defined as visible in the Screen Painter can dynamically be made invisible by using the statement screen active is equal to 0. Using this statement has the same result as the 3 statements: screen invisible is equal to 1, screen input is equal to 0, and screen output is equal to 0. For complex transactions, you need to use multiple screens. You need to determine the initial screen while creating the transaction code. Each screen leads to the next screen according to user input. The next screen is entered statically in the screen attributes. At runtime, you can temporarily override the static next screen by using the set screen statement.
You can establish a static sequence of screens by entering a value in the next screen field of the screen attributes.
The set screen statement temporarily overrides the value assigned to the next screen attribute. The screen must belong to the same program. The next screen is processed either when the current screen processing ends or when you terminate processing by using the leave screen statement. To specify the next screen and leave the current screen in one step, use the leave to screen statement.
You can insert a screen sequence in a program. Adding a screen sequence adds a layer to a stack. You insert a screen sequence by using the call screen statement. Note, layers created in this way must be removed later by statically or dynamically setting the next screen to the initial value, that is 0, at the end of the inserted screen sequence. To interrupt processing of the current screen and branch to a new screen or sequence of screens, use the call screen statement. The screen must belong to the same program. In the program, the system constructs a stack. To return to the statement following the call screen statement, you can use either the statement set screen 0 followed by the statement leave screen or the statement leave to screen 0. The screen that called the other screen is then processed further. If you use these statements outside a call chain, the program terminates and control returns to the point at which the screen was called. You can also terminate a program by using the RBAP statement leave program.
When a system displays a screen, it automatically places the cursor in the first input field. If you want the cursor to always appear in a different field, enter the corresponding element name in the cursor position field of the screen attributes. You can also indicate the field where the cursor should be placed in the process before output or PBO event. Indicating the field in the PBO event makes your application more flexible.
In the call screen statement, you can use the starting at and ending at additions to specify the position and size of the screen that you are calling. You must define the screen in the call screen statement as a model dialog box to comply with the ergonomic standards of an SAP system. If you omit the ending at addition, the size used in the screen attributes determines the size of the dialog box. The system determines the size of the dialog box by using the occupied size screen attribute. If you use the ending at addition, the system displays as much of the dialog box as will fit into the available space in the screen. If the space is not enough to show the entire dialog box, the dialog box appears with scroll bars.
The starting position or origin of every window in an SAP system is its top left corner.